So this year we're transitioning to electric, and we have a third-year design team dedicated to designing a electric powertrain. So Ciaran, can you tell us what you've been doing in the project so far?
We took the QFR 19 chassis as a basis to start off with, took measurements of the size available for the engine, and went with this for trying to size up our accumulator. Obviously, taking into account that the battery or the motor will sit at the back within the chassis as well. This gave us the basis to start on the CAD model to try and incorporate some sort of size measurements for what we have available to us. We then went about looking at how we were going to create this capacity of battery, keeping in mind the endurance event and the acceleration event, trying to find the balance between obviously energy storage against power required to accelerate the car as quick as possible. We've done this using MATLAB script all online, which then gave us figures and requirements from our battery. We then went about speccing the batteries would fulfill these requirements, which turned out to be 18650 cells, cylindrical cells, mainly due to safety reasons over the pouch cells, which can quite easily enter thermal runaway, which would basically result in a fire.
So how's the chassis shape going to change now that you have an accumulator instead of engine?
So due to the engine being taken out and the electric vehicle powertrain being added, obviously we no longer require the fuel tank. So due to this fuel tank going, we can now move the firewall closer to the seat, giving us a lot more space available here. The cross member sitting here can be raised up slightly to accommodate for more height due to the BMS and all those other requirements within the accumulator. So that gives us a little more space as well. Obviously the QFR 19 chassis was actually shortened to be optimized for the R6 engine. This can be lengthened back. So then obviously we have more space available for the motor at the back. Then once we have these lengths, we can then try and look at the width. So due to these high voltages, high currents, we have huge conduit wire which will be carrying up to 500 volts, 200 amps. So these obviously require a lot more space as well due to bend radius, because we're using 35mm squared wire, which is quite thick wire. So once we get these sidewalls in, we can then look at cooling, which is one of the biggest problems with this year's accumulator, was trying to find the spacing for the cooling. So obviously because it's quite big, we try to push it out wide, because we were struggling lengthwise, which then means that if the cooling's coming on the side, we need quite a lot of space to turn the duct from the side pod round into the accumulator.
So obviously you've only had like 9 months to do this project, but in future years, is there anything you think they'd do differently or add in that you haven't had time to do?
I think that in general, I think pouch cells might be the way to go for weight saving and stuff like that. So I think in the future we'll go down the pouch cell route.